Hello everyone, this is the video demonstration for EE542 Lab 11 xDot. So in this lab, we configure our xDot, we connect the thermistor to this xDot to collect temperature data, then send it to a gateway, and then from the gateway, we further send it to AWS for further data collection and also processing. So let us start. So in step 1, we're going to connect our xDot to the PC. So this LED3 should turn on. So just to show it as power. So after that, we got to install this driver. So this driver is going to make sure that the xDot can communicate with our PC properly. So after we do that, these ports should be available, the m.serial port and also a command port. So let us go to device manager to check it out. So right here we can see in device manager, we can see we have the embed serial port that's for debugging to get input from the xDot, and also the serial device that we're going to use it for AT communication. Basically communication between the xDot and also the conduit. So we're going to see this later on. So first we gotta basically create an account with embed. This is going to be our environment and IDE where we're going to create our programs. So our first program is going to be a simple program known as Blinky, where where the LED is going to turn on and off every 500 milliseconds. So and we're gonna basically check out the debug port where the embed is where the xDot is going to send data to our PC. So let's go ahead. So what we do is we go to the xDot folder, pretty much like a drive, almost like a removable hard disk drive. So we click this link. So when we do that, it'll lead us to this page, and we gotta use the Blinky program. So we can see that this program should be available here. So we go to this link. Okay, so we have this program. So what we do is we import to Kill Studio. So I already have it in the the environment. So let's go there. So after we import, this whole program will be available in the our environment. So let us go here, and this program should be here. Yeah. So you can see we have the embed OS Blinky. Let us change that to the active program. And when we go to main.cpp, we can see the program. So basically what we do is we turn on and off the LED every 500 milliseconds. So you can see we have set the blinking red 500 milliseconds, and we're basically turning on the digital out pin. That's to give power to the LED. Basically, set it like so it can turn on. So we have a loop, and we're gonna put it we're gonna like make it sleep for every 5 milliseconds. So we can see that every 5 milliseconds it's gonna turn on and off. So for the debug port, we're gonna have a printf statement that's gonna say hello from xDot. So what happens is when we would go to the debug port, we should be able to see this. That's why we have the statement. So we can check out the debug port. So let's compile this program. Okay, the build has been succeeded, and we have this bin file. So we have to copy this bin file into the xDot. So this is the bin file. Let's just simply paste it into the xDot. So when this is happening, the SDA LED of the xDot should keep blinking like really fast to show that the xDot is being flashed with the new program. So after this has been complete, we have to press the reset button so that the most recent program will run. So after this, the LED will blink every 5 seconds to basically verify the program's running. Let's go to the debug port. So before that, we have to make sure the parameters of the debug port and also the COM port and the xDot have the same parameters. To be more clear, so this is the debug port. So we can see the bits per second has to be 9600. All these parameters should match with what we are entering into the putty. Yeah. So the embed serial port, again 9600 as we saw in the device manager, and the same parameters. Okay, so we got it. So we can see it's printing hello from xDot due to the statement into the debug port. So we can see this program is working, and the LED should blink every 500 milliseconds. So yeah, so let us go to the next step. So we can see this step is complete. And now for the thermistor part. So what is happening here? So basically we have a thermistor. Thermistor is nothing but a device that whose resistance changes as temperature changes. So the thing is, the xDot can't measure the resistance. It can measure voltage. So we know voltage as a voltage has a direct relationship with the resistance. V is equal to IR and V is proportional to R. So changes in voltage, changes in resistance can be shown with the changes in voltage. So that's exactly what we're doing here. So we feed the voltage input. This is going to be 3.3 volts, and then we're going to connect the thermistor, and then we're going to connect a 10 kilo ohm known resistance. So we're connecting a known resistance. We have a known resistance because we'll know the voltage drop across this resistor, and then we have the ground. So what's happening here? So input we're feeding 3.3 volts, and obviously the voltage drop should match the 3.3 volt drop according to Kirchhoff's law. So what happens is, as the temperature changes, the voltage drop across this will change, and obviously concurrently voltage drop across this will also change due to the temperature change. So due to this change in due to this change, the voltage drop will change. We are measuring this voltage drop, and since the resistance is known, we can find the RT, and concurrently we can find the temperature in centigrade. So that's what we are doing. So let us look at our circuit. Okay, so this is a circuit. So we have a breadboard here, and this is the emulation of the circuit in physically. So this is the 3.3 input voltage input here, and then we are connecting the thermistor. So you can see this is the thermistor over here, and then we are connecting the 10 kilo ohm resistance, known resistance in series, and then we have the ground connection. Uh, So what we're having is we're taking the V out across the known resistance right here. So this is the known resistance voltage right here. So it forms this circuit. So this is a simple circuit, and this is the xDot. So the thermistor circuit is complete. So right now, after this, let us look at our code. So same Keil Studio. So this is the thermistor code that we have done, and let us look at the program. So it's very simple. So let's look at it. So obviously we're going to print a temperature test program in the debug port, and we're going to set VC equal to 1. So what happens is, so this is the port. So digital output. So GPIO0 is the port we connected the 3.3 VCC in the circuit. So we turn it on. That means it's going to give 3.3 output. So we have that, and then what we're going to do is we put in a loop, and we're going to read from the digital. We're going to read from the analog in. So we have the analog to digital converter in the port PB0. So this is going to convert the analog voltage in the range of 0 to 3.3 volts to a set digital value, simply like a mapper. So we're going to get the digital input here in val, an integer, and we're going to basically put it into this function that's going to convert this digital value into a human recognizable temperature centigrade value. So we do these functions, and then we get the temperature in centigrade. And what we do is we basically print this temperature, and this is done every 500,000 microseconds repeatedly. So let us build this program. Okay, so let us build it. Okay, so it is complete. Just copy the code into the xDot. So let us press the reset button and the temperature measurement should start. Okay, so we can go to the comport. Yeah, so we can see I'm getting the current temperature from the xDot. So when I move the thermistor closer to my body, it should move closer to my body temperature. Yeah, you can see it increases towards my body temperature, and we were getting the correct values. So we can see every 5 microseconds, it's reading the temperature value from the thermistor. Now Ananya will explain our visual demonstration in the lab.
Now let's get started with the thermistor part. So we have purchased the thermistor from Amazon, and we have even got the 10 kilo ohm resistor. So now we are going to connect basically the thermistor to the 10 kilo ohm resistor serially. From there, we connect it to VCC and ground. So this is how the circuitry will look. Let's check this link. So here we can see the connection with an Arduino board, but we will be replacing it with the xDot. Basically, we have the xDot here, and we are going to do the calculations for that, which is here. And this will be incorporated in our code as well. So now let's look at our code. So this is the code here. We are connecting our PV0 to GPIO2, and GPIO0 is set to VCC, which is basically used to power up our thermistor. And here the VCC value is set to 1, that is to supply the power to our circuit. The sensor reads the 16-bit unsigned value, and the ADC will convert it into the temperature value in Celsius. We do some calculations here to convert from Kelvin to Celsius, and this is how it mainly looks. The code and the readings are given every 5 seconds. Now here we can see the output of our code. Initially the temperature is around 18, and once we place the thermistor near a heated object, we can see that the temperature gradually increases from 18 to 19 and it goes up to 23. Here we can see the output when with the thermistor. And now let's look at the connection. So this is the xDot which is connected to our thermistor. We have connected the ADC out to GPIO2 and VCC to GPIO0. Then we can see that our resistor, which is the 10 kilo ohm resistor, is in series with the thermistor. So this is the connection that we have set up. We can even observe the voltage here now. So we can see that at this point, by using the voltage divider rule, the voltage comes up to 1.5 volt, and the VCC voltage is around 3.3 volt, which is the required voltage.
So the first step here is to mainly connect the xDot and the conduit. So we have to import this .at firmware program for that. So this is where we can import it from. We are using Keel Studio for this. And as you can see here, it's already imported and it's renamed as LoRa conduit. And this is the main file. But since we're using xDot, we need to separately import libx xDot embed library. This is not directly available to us. So like it's given in this case, it's not included. So we just go here and we download the version which is suitable for our case. So in our case, the suitable version is version 5. So we have downloaded that. And the same can be seen here as well, that the version is 5. So whichever one is compatible, we have to go ahead with that. And once we download it, we have to build this program. And suppose that we'll find the bin file here on the desktop. We just copy this bin file onto xDot. So as you can see, it's getting copied. Once it is copied completely, we just have to press the reset button on the xDot so that we can start running it. And after that, we have the setup ready on Node-RED. And we have to basically type these commands in order to enable the communication between the xDot and the conduit. So we are basically selecting COM port. We are going with COM 10 here. And the speed in this case will be 115 to 100. So we are just typing the commands that are given here in the PDF. So we are just giving the commands here. So the first command, as you can see, we got the output as OK. Now we are basically trying to connect to the conduit, and this is done using the network name and the network passphrase. So in this case, it's Pratig underscore LoRaWAN. That's the network name. So as you can see, we got OK as the message. So we are just typing all these commands one by one. So since all the commands are successful till here, we basically want to connect with the conduit. So we have used this command at plus join for that. And we saw that we successfully joined the network. Now, since the connection is successful, we can send messages to the conduit. And these messages can be viewed through Node-RED setup that we have earlier done. So I'm just showing the setup in this case. So whatever message we send here, it should be received by the conduit, and that can be visualized in Node-RED. So in this case, we are just sending a message hello. So that should be seen here. As you can see, we are able to see that in Node-RED. We can try to send another message as well. And we got that message as well. So we know that both the conduit and the xDot are communicating successfully using this setup. So we have done all these steps. The next step is to execute this OTA underscore example program. It is available in dot examples. So we just go to that link and we basically import this program that is already available. So you can see in dot examples, we have it. So we just import it. We have already imported it in this case. So here we can see that the program name is given, which is OTA underscore example. So this basically specifies that we are going to compile and execute this program. So this is the code that we have. We are basically trying to send a message called EE542 to the conduit. And this is a simple program wherein we are declaring a character array, and we have E542 in that. And we are basically looping through that so that we can send this data. So we first push it into a vector, and that vector is then sent to the conduit. So as you can see, we have the send data function here, and we are sending transmitted data, which is nothing but the vector. So we just compile this. We again get the bin file, and we have to copy it to the xDot, reset it, and then run it. So we are compiling it in this case. So one thing to make sure is to check the versions, because the version of .lib library is very important. Otherwise, we'll get errors in compilation. So this basically again shows the .lib version that we have downloaded. So we got the bin file in this case, and we just try to see if we are able to send the message. So I'm copying the bin file into xDot. So once it is copied, we can see if we are receiving the message at the conduit. So we just go to Node-RED and we can see that we are getting the message EE542.
So let us look at the final part, where instead of EE542, we're going to send the thermistor sensor data from the xDot to the conduit. So let's see how this is done. So it's very similar to the previous code of EE542. So what we do is, so we have the, so basically we read the, as previously seen in the thermistor code, we read this, we read from this pin, and then we feed it to the thermistor function. It's over here. Yeah. So we are having this function, and then we return the temperature, and this temperature we're gonna using sn printf, we're gonna feed it to a vector called out, right? So after that, what we do is we so after sorry, we put it into a character array called out. So after feeding into this character array, we push it. We basically feed index by index into the vector called tx data, and in the end, we're gonna send this tx data to the conduit over here, right here. So let us do that. So what I'm going to do is I'm going to save the program, and then I'm going to compile it. So we can see the program compiled as a success. And now let us copy this code into the xDot. Okay, so this has been completed. So what's going to happen is this sensor data should be printed, should be available over here. As this LoRa block receives the temperature data, and also since we have included a printf, it should also be available in the through the debug port. So let's do that. So I'm going to press the reset button and let's check it out. So first I'm going to go to the debug port. Okay, so we can see I'm getting the current temperature values, and now let us go to the Node-RED. Yeah, so we can see that I'm getting the temperature values in the Node-RED of the conduit. So we can see right here, right? So we're getting the values. So after this step, so after now that this step has been completed, yeah, we can see we're continuously receiving the temperature measurements from the thermistor in the conduit. So after this has been completed, what we're going to do is we're going to send this data through our AWS instance, right? So and we're going to visualize using ThingsBoard. So we have our AWS instance over here. So I have this particular instance running, and we have this IP address. So let us reload. So we have this instance, and we're going to SSH into this particular instance. So we've done it over here, and we can see this. We have Node is already running. Oh, sorry, it's this one. Yeah. So this is our. We can see this is our instance. We SSH using this IP address as seen here, and then we have started ThingsBoard. So let us go to the Node-RED of the conduit to see how we send it to the ThingsBoard first. Okay. So what we do is we connect it. So basically we have message.payload that's going to contain the temperature. That's going to contain the temperature values. So we put it into thingsboard function to stringify it, to convert into a JSON string, so it can be sent over HTTP to the AWS instance. So when we go here, we can see this is the payload. So we put it into a JSON function, and we're gonna have the key as the temperature in centigrade and the value as the message or payload. So let us connect to the HTTP request. And then the HTTP request, obviously we have the URL of, okay, yeah, right here. Okay, so I'm gonna have the URL of this particular device. So I named it temperature. So let's go here, and I'm going to include the obviously the access token, right? So the IP address is going to be this IP address of the instance. Seen here, 8080 is the port that Thingsboard is using, and this is the this is the token that we copied. So when we have that, this is gonna send this temperature, these values. So let us now go to Thingsboard. Okay, so this is the device we're using. So what we do is, just to recap, we have to copy this access token and paste it over here. So the gateway is going to send the data to this particular device in Thingsboard. So when we go here, we can see this is going to be the IP address of the AWS instance again, and then this is going to be the token ID of the particular device. So the data will be sent to that device. Now that's done. Let's go here, and also we can see we are sending with the label of temperature in centigrade, and message or payload is going to have the temperature. Let's go here. Yeah, so this is the device, and when we go to latest telemetry, we can see we are getting the current values in this particular section, telemetry. So 24 is the room temperature, as I have kept it on the table, and let us visualize it. Sorry. We can use the digital gauge so it can be more intuitive. Okay, so now the room temperature is 23. Now when I bring it close to my body, it should be close to my body temperature. Should increase towards my body temperature. Yeah. So you can see when body close to kept from my body, it is close to my body temperature. So we can see this is our thermistor circuit. So we have the xDot here. We have the breadboard here connected to the thermistor over here. That's reading the room temperature. So when I bring it close to my body, it should increase towards my body temperature. So that we have the visualization with the Thingsboard in an AWS instance using xDot and also the multi-tech conduit. So thank you.